Hi, Lilia. Thank you for coming on to the podcast today. And yeah, I'm excited to learn more about Zylotex and where you came from and what you're doing.
So what we're doing is we are developing an advanced material in terms of regenerated cellulosic using hemp bast fiber as a feedstock.
Okay, what is cellulosis?
Cellulosic?
Yes.
Cellulose is the most abundant natural polymer in nature. So it's found in all plants and
Mm-hmm.
it is the basis of all plant structure. So what we're doing is we're really harnessing structure from nature and converting it through a semi-synthetic process to produce a material that is even consistent and applicable to numerous industries.
So, what kind of applications does this product have? Like, what does it look like? We'll have to really break this down.
Yeah, okay, so when you talk about the textiles, so we're talking about the textiles world.
Uh-huh.
And the type of fiber that we are producing is called lyocell. Now, lyocell has been around for about 30 years in the industry. So if you've ever worn anything called Tencel, that's a brand name by a company called Lenzing. There's also other types of regenerated cellulosics that you may be familiar with, like bamboo or rayon or viscose. But what's really unique about what we're doing is we are harnessing hemp bast fiber, which has some really interesting properties to itself,
Mm-hmm.
to really make an advanced lyocell material. What's really interesting with what we're developing is we could create a fiber that could be applicable to industries like nonwovens. And you're thinking, what is a nonwoven? Well, nonwoven is everything from geotextiles, so materials used for erosion control, roadway infrastructure, even building materials,
Mm-hmm.
to something like even bale wrap, so bale netting for an agricultural purpose.
Mm-hmm.
Additional applications would be composites, so think about car paneling. So if companies want to start using materials in their car panels that are more sustainable, environmentally friendly, that are also light, this would be a perfect substitute.
Interesting. So, are you harvesting hemp? And then, like, what does that look like?
So we don't harvest the hemp, but we are working with a company called Planty Technologies, and they're working directly with the farmer to work on different cultivars and seeding rates for optimization of the straw. What's really interesting about our process is we are valorizing, in other words, using the residues from food and oilseed crops. So
Okay.
we're using a crop that is already existing, but the straw doesn't have a home.
Mm-hmm.
And what's interesting about the hemp plant is it can grow upwards of 10 centimeters a day. This is why we're really interested in hemp, because it can create so much biomass, especially when we're looking at a dual purpose crop,
Mm-hmm.
like an oil seed or food crop.
Yeah, okay, that makes sense. So basically, an oil seed like canola,
Yes,
where you're taking the seed for the oil itself, but then the plant itself is generally wasted. So
yes,
you're saying you can take that waste and then use your process to turn it into usable fibers.
exactly. So what's
Amazing.
really neat is Planty Technologies takes the straw and they separate it into its components. So a hemp plant, if we do a comparison compared to a tree trunk, for example, so trees have the wood core and then the bark outer.
Mm-hmm.
Hemp is very similar in that there is something called hurd in the middle, which is the woody portion of it, and bast fiber, which is the bark portion of it. We are interested in the bast fiber because that is really considered as a waste stream right now. The hurd is being used in other markets like building materials or composites, but the bast fiber, again, not being used. But what's interesting about the bast fiber, and if we compare it, we're going to go into a little bit of science here. If we compare it to, say, traditional wood fiber,
Yeah.
it has a higher alpha cellulose content. So we're going back to cellulose, that the most abundant natural polymer
Mm-hmm.
available. And hemp bast fiber has this really high amount of alpha cellulose, upwards of 70 to 75%, whereas wood has about 45 to 55, depending on the type of tree it is.
Okay.
Why this comes into why this is so important is we have to go through the pulping process in order to break down the feedstock and separate it from non-alpha cellulose components. So there's things like lignin, pectin, extractives, ash content
Okay.
that are all part of this natural material. And if you start off with a material that has a high alpha cellulose content to begin with, then you could break it down faster to get the end pulp faster as well. So you actually end up using less energy, less chemistry to reach the same type of product.
So it's just basically more pure,
It is more pure.
in whatever.
Yeah.
Yeah. Okay, that makes sense. So, you know, you're a scientist. I could gather that. But like, what's your background that got you into this specific, field?
Pardon the pun. So I am a textile scientist. So I have a undergrad in human ecology, master's degree in human ecology, and now I'm currently pursuing and completing my PhD in human ecology. And in human ecology, I really focused on textiles and clothing.
Mm-hmm.
So within this world, I work primarily in the personal protective equipment market for quite a few years.
Yes.
So that's working with garments for protection against flames, for example, against fire. But what happened? Okay, I'm gonna back up. I'm gonna back up a little. Boop,
All
boop,
good.
boop, boop,
Yeah.
boop. Okay, so
Cut.
cut. So I was working with personal protective equipment, particularly for materials for personal protective equipment and flame resistance.
Okay.
I was working for a company called Davy Textile Solutions, and in 2017, in the R&D area, in 2017, I was looking for local sources of fiber. So Davy Textiles is a manufacturer of high visibility striping.
Mm-hmm.
And we purchase a lot of the yarn from Eastern Canada, from a yarn spinner in Eastern Canada, but they sourced all of their fiber, they imported everything.
Okay.
So after doing my research at Davy, I found out that there is essentially less than 1% of all fiber produced globally is produced in Canada. So Canada essentially doesn't produce any fiber.
Yeah.
So when 2018 came along and we had the Cannabis Act put in place, that allowed for whole plant utilization. And this is really interesting because this ties back to my undergrad roots where I did a lot of work on hemp bast fiber, looking at degumming it. In other words, removing the lignin and the pectin in order to extract this beautiful bast fiber.
Mm-hmm.
So I thought this is a really great opportunity to capitalize on a plant that's been used by humans for millennia for textile applications.
Mm-hmm.
What I found out very quickly is that hemp grown in Canada is primarily grown for hemp food and oilseed production.
Yes.
So as a result, this is an older plant. It does grow really tall, but it's also really old, meaning that it's higher in all of these non-alpha cellulose components. So it's not very conducive for textile applications just off the field. It's extremely coarse. It looks like really coarse straw. And it's something that if you are thinking about a textile and thinking about a shirt that you want to wear, you would not want to wear this material.
Okay.
So then I was talking to my colleague Wade Shute, and he previously worked at the Alberta Research Council working on pulping alternative feedstocks. And he said, why don't you consider something like a regenerated cellulosic? I thought, well, that's a very interesting idea. So we started to collaborate, working on pulping different hemp and bast fractions. And we found that this material was quite suitable for the lyocell process.
Mm-hmm.
And that's where this all sort of came to full circle, utilizing hemp, but in not quite the mechanism that I wanted to in the first place as a traditional bast fiber, but instead into something a lot more advanced.
And when did this kind of eureka moment happen?
It happened in 2019, 2018, 2019, really when we started investigating what hemp was available for use in Canada.
Mm-hmm.
So in 2022, I approached the University of Alberta and asked Dr. Patricia Dolez in the Department of Human Ecology if she would be interested in working with us on this project. And she said, absolutely, this sounds fascinating. So in 2023, I went back to university to complete my PhD. I did leave my PhD studies in 2015, so this is a perfect opportunity to get back into university.
Mm-hmm.
And since then, I've been working with the research team to develop different methods on pulping and spinning. But since then, we have incorporated Zylotex and taking those findings and doing additional work with Zylotex to commercialize this fiber.
I see.
Yeah.
And so who's on the team now?
So the team now consists of myself. So I am the founder and chief technology officer. We have Wade Chute, who I talked about previously.
Mm-hmm.
He is also a founder, and he's also the chief technology officer at Plantain Technologies.
Mm-hmm.
And we have Ken Barker, who is also founder and chief executive officer. What's interesting about Ken is that he worked with Wade almost 20 years ago on this exact same project.
Oh, wow.
But unfortunately, hemp at that time was illegal to be grown in Canada.
Yeah.
So the world wasn't ready for this technology, for this research, for this really amazing fiber to come into play.
Mm-hmm. So my next question is, how far have you gotten so far in the development process?
We've essentially proved on pilot scale both the pulping and the fiber spinning. So really we just need to scale up. We have demonstrated on fairly large scale that we can do this.
Mm-hmm.
We essentially need cash, money.
Yeah. Operating capital.
Operating capital, thank you very much, in order to really bring this to fruition.
Yes, I see. So are you fundraising right now?
We absolutely are. So I did apply for a substantial grant last year. I can't name the name of the organization since we need to raise matching private funds before this is disclosed. But we have received a substantial grant for $3.75 million, of which we have to raise private matching funds for an additional 3.75.
I see. And then that 7.5 million, where does that get you?
That'll really get us into the pulping space. So it'll allow us to scale up pulping, and it'll allow us to start producing the amount of material required for fiber. And then we could do toll manufacturing of fiber until we can actually have a lyocell manufacturing facility in place here in Canada.
Makes sense. And then this finished fiber, who are you able to sell that to, or what's the next step for it?
Right now, we have signed offtake agreements for about 1,800 tons per year. The initial plan for the lyocell plant was for 1,200 tons per year, so we are technically already oversold. And we have a lot of letters of interest from quite a few national and multinational companies. So we do have a substantial interest in this material. A couple reasons why. First of all, this is an environmentally friendly circular material. It is biodegradable, it is compostable, and we are valorizing a residual from a food crop. So as a result, we're able to meet 9 UN sustainability goals. So it is quite a fabulous environmental story. Secondly, there are organizations that are looking for tree-free alternatives. So regenerated cellulosic materials or man-made cellulosic fibers are right now majority being made from tree fiber. So there is a pushback in the industry to move towards tree-free fibers or tree-free solutions. So we provide that opportunity for a tree-free solution that is also environmentally friendly, more environmentally friendly, is also just as cost-effective or cost-effective. So it is economical.
Yes, that makes sense. Really interesting. So then, what does the finished product look like? What when you say 1,800 tons? What 1,800 tons of string?
What? So we are going to be a fiber and film manufacturer. So there's different applications depending on the end use application. So if we need something with a higher tenacity, a higher strength, we would want to produce a monofilament. So something that essentially looks like fishing line. A little bit coarser. If we want something that we want to then spin into a yarn, think of, for example, a dental floss application or for medical sutures, then it would be a much finer material and it would look like fluffy, almost like a cotton ball type of material, very, very light and fluffy and white. And then in terms of the films, think about cellulose acetate films that are currently used in packaging. So what you would buy, when you would buy a package of pasta, the plastic that it's in, we want to replace that with an alternative that is biodegradable and compostable.
Really interesting. So it can even take the place of plastic in some situations. Interesting.
And this would be a true bioplastic. And not plastic, it'd be a true biofilm material.
Wow, that's really cool. And so you already kind of answered the question, but in terms of the big picture, 10 years from now, everyone uses it for like all sorts of things. Like, what's the potential impact? We already know lots of sustainability goals, but in general, how can you change the world with this?
So right now, the next generation fiber market, and this pertains to materials that are looking towards sustainability, circularity, that are either looking at recycling post-consumer textiles or creating materials that are themselves compostable, biodegradable, or can be recycled back into something else. That's currently a $40 billion market. Canada currently has zero market share.
Uh-huh.
So where I see us in the market within the next 10 years, I foresee that we're going to be in the millions of dollars, potentially
Mm-hmm.
even billions, depending on where this goes,
Mm-hmm.
because we are in Canada, we are natural resource rich, and we can take these, something like a food crop that could be grown on a 3-year rotation, and we could really exemplify the agronomy world in terms of regenerative
Mm-hmm.
agriculture and become leaders in this space.
That makes sense. Yeah, you're sitting on the supply, and you just need to find a way to use all this stuff that
Yes.
already exists. That's
Yeah.
uh-huh.
And one of the goals that we have right now is working with a local Canadian company to produce to produce a 100% made in Canada t-shirt from ground up to t-shirt back
Mm-hmm.
down to soil. So a completely
Wow.
circular system.
Wow, that's really cool.
That's also comfortable to wear.
When can we buy the shirt?
We're hoping in 2028.
Cool. Nice. And then otherwise, we are at the engineering incubator. And
Yeah.
how long have you been a part of that?
I when did I sign the documents?
Roughly.
It was summer.
Yeah.
So I became part of the ice incubator in summer of 2025.
Yes. Cool. And how have they been able to support you as you build the business?
So I've been involved in a few different accelerator incubator programs, and every single one has just been phenomenal in terms of the support.
Mm-hmm.
The mentorship has been amazing. There's also the freebies, which are always good, and in this case there was a law firm that was involved that did provide some legal counsel,
Yeah.
which has been absolutely amazing and has really helped us build our corporate structure.
Mm-hmm. Oh, that's good to hear. And we're gonna cut that off there. I actually do not know what else to ask about it. Just I try to do the plug. But yeah. Otherwise, I guess any other cool things that you want to share? That's so what's coming up? What are you excited about? You know.
So what I'm excited about is we actually are going to be running some trials at Innovator, Alberta to scale up our pulping,
Mm-hmm.
and we are going to start producing fiber overseas to start off with, but eventually in Canada.
Mm-hmm.
And I really look forward to seeing Canada be an industry leader in the textiles world.
Mm-hmm. And you think you can be a part of making that happen?
Absolutely.
Yeah, amazing. All right. Well, thank you so much for coming out and yeah, telling us more about Zylotex. And yeah, I can't wait to wear the shirt.